Okay, this is really for everybody that's in fifth and sixth period, or anybody who's absent who just wants to get caught up and just see what's going on here. This is where you guys got to in class. Just because you have a shorter class, you have 5 minutes less class every single day, which adds up. You look over a course of a week, that's 20 to 25 minutes less learning each week, and that's why you guys usually aren't at the end of things. You come into class, it takes a little while to settle in after lunch. So we got through this, and on the trapezoid page, this is 9.1b. On the back of the page, we talked about trapezoids. We never got through any real examples of it, so I want to make sure you have some time to work some examples. And I haven't collected that packet yet, so you might go back and rework some of the packet on here based on this. So these are the 3 different versions of the trapezoid formula. Mid-segment times height is one of them. That's the simple version. Some people like that. This is your textbook version of it, where you do 1/2 height times the addition of the bases. I like this one, which you can really look at it. That's the average of the bases multiplied by the height, which kind of makes sense because when you think of area, most of you think of area as base times height. This right here is really just base times height, but a trapezoid has 2 bases, so before you do base times height, you got to find the average of the bases, which is really the length of that little mid-segment that would divide through here or divide through here for the trapezoid. So here are the examples. I don't think you got through too many of these. You guys may have started this first one. I suggest you pause it. If you haven't done this one yet, pause it and try this one. That's all the information you need to solve that first one. You can, and I'll keep talking, but you can certainly pause it. You can draw a little altitude this way. It's a little weird, but these are the 2 bases. The height is actually going this way. It's this side. If you draw this in here, you'll see you get some Pythagorean theorem. If you draw that, this little dimension here is 9 and 11, dividing the 20 into 2 pieces on there, and eventually you can figure out that's 12. And you're certainly welcome to work ahead if you already did this one. There's enough information on these 2 to keep going. And then it's just average of the bases. So 31 divided by 2, which is 15.5. And multiply the mid-segment. That 15.5 would be this dimension times the 12, and you get 186 square units. And hopefully by the end of this, this type of problem becomes a pretty simple one. First couple, it's a little weird what you're trying to work on here. Second one, I'm giving you 2 sides, 10 and 10 and a 40. This is going to be a trig-based problem. Hopefully you're thinking you got to draw an altitude because you have 1 base, but you don't have the height, and you don't have the other base. I believe that height ends up being 6.43. If you draw the altitude here, you can call that h if you want, and then use a sine ratio. Sine of 40 is equal to h over 10, and that's where that 6.43 is coming from. The other thing that's going on here is you look at this 10 dimension. This 10 dimension can be carried down to the bottom. This is 10 units long. You can ignore that for a second, ignore the 10. You can find this length using a cosine ratio, or using Pythagorean theorem now, I guess. And you should get like 7.6 for that, which means this entire thing is 17.66 something, something, something. Because I've added the 7.66 to the 10 that would be here, the whole quantity 17.66. From there, I think it's, once you got those 2 big steps, you got the height, you got the little piece of the base over here, average the bases, you should have something around, I don't know, 12 or 13, 13.8 I guess. Multiply the 13.8 by the 6.43, and you've got your area of 88.9. Again, I'm going to go through this kind of quickly. For those of you that are fast, go for it. If you're not fast, take your time and kind of work through this. Again, you might draw altitudes here. Probably should draw a couple altitudes here to cut off the wings of the trapezoid. And you end up with 5 rad 2, if you do it exact, or 7.07 for these sides. And of course, if that's 45, and this is 90, this would have to be 45. So this leg has to equal that leg. So these are both 7.07. And the same thing on the other side. You got 7.07 here and 7.07 there. It's a nice isosceles trapezoid. So the whole length of this would be 7 plus 7 plus 8, which is the entire base length on there. You should eventually end up with about 15 for the mid-segment and about 106 for the area. Now these are the last 2 in that sequence. This answer, you're trying to get an answer in terms of x. These are some dimensions over here outside the trapezoid. So 4x, 6x, and 2x. This is 3x. There's a little right angle box on the outside. This one's got a 30-degree angle, so it'd be great to do that one with 30, 60, 90 ratios. That's 12. That top is 10. And like I said, this answer, give your answer in terms of x. Hopefully you realize that there's extra information here as you're working through this. The mid-segment is just the average of the two bases. So 6 plus 2 is 8. Half of 8x would be 4x. So the mid-segment's 4x. Once you have the mid-segment, all you have to do is multiply by the height. That's the average of the bases. This is garbage. This is your actual height. 4x times 3x is not 12x. A lot of people in the other classes wrote 12x as the answer. The answer is not 12x, not even close to 12x. It's 12x squared, which is dimensionally totally different. This allows you to have square units. If you said it's 12x, yours is x times too small. So if x was 10, say, if this was 20, 60, 40, and 30, your answer would be, 120 here instead of 1,200. Not even close. So the x squared is critical. You have to be able to write things in terms of x. This is sort of an algebra review of dealing with an exponent. The last one on there, if you draw an altitude, that's pretty quick because you create a 30, 60, 90. If that's 12, that's half of it. That's 6. This would be 6 rad 3. 6 rad 3 plus 10 gives you the entire base. And I think you end up with 15.2 for the entire mid-segment and 91.2 for the total area on that. So show your calculations on how you get those. I'm just going to try to give you a chance to check some areas on there as you're working through. So that hopefully that gets everybody up to the same spot in all the classes. I don't think there's anything else I missed out on. Good luck. Hopefully everything works out well. We'll see you on Monday.